the other example of homogeneous equation. So we have an equation of x cosecant y over x negative y dx plus x dy equals 0. The first thing we need to do is to identify which is the n and n. So in this case, the n is this part and the n is this equation. So we need to identify which among these is the simpler. In this equation, this is the simpler. Therefore, y is equals to, since n is simpler, since this is the simpler, therefore y is equals to vx, then dy is equals to v dx, this is small letter, is equals to v dx plus x dv. Since we already identify which among this is the n, so we need to simplify this equation. So distributing the value of y and dy, yung nakuha natin kanina, so rewriting this equation into x cosecant, since ang value man sa y is equals to vx, so we just put this value in here. So vx is equals to x, then y is equals to vx. Since the value of y is vx, dx plus x, and the value of dy is v dx plus x dv is equals to 0. So we need to simplify this, so cancel out x. So we have x cosecant v minus vx dx. Distribute the value of x in this equation. So we have v x dv plus x squared dv equals to 0. Then rewriting this equation, distribute dx in this equation. So we have x cosecant v dx minus vx dx plus vx dv plus x squared dv is equals to 0. So cancel out this, since this is negative and positive and they have the same variable, so we need to cancel this. Rewriting the equation, so we only now have x cosecant x v dx plus we have x squared dv is equals to 0. So this is not our final answer. We need to separate this equation using separation of variables. First thing to do is to find their common value. So we have this x over here and x over here. So we need to multiply both sides by 1 over x and 1 over x. So we can cancel the value of x in here. Therefore, cancel the x, cancel x and x. So writing the equation, we now have cosecant v dx plus x dv. Since we still didn't separate this value of b and this x in this value, so we still need to separate this equation. So since we still haven't separated the value of b in this equation and the value of x in this equation, so we need to separate that using separation of variable again. So finding their common denominator, so we need to multiply both sides by 1 cosecant, we have b cosecant b, and we have x both sides, so 1 over cs cosecant b of mx, since this is their common denominator. Cancel the value of x in here and the value of cosecant b in this equation. So distributing the remaining variable in this equation, so we will have d over x plus dv over cosecant b equals to 0. The next step we're going to do is applying the integration. So we need to apply the integration in this. Apply the integration. The integration of dx over x is ln x plus the integration of dv over cosecant b is simplifying that will become a sine b, then sine b dv, and this 0 will become c, which is c represent as constant, then n x. The integration of sine is negative cosine, then negative cosine times positive is equals to negative cosine v is equals to c. So let c is equals to I and c. So we need to transpose this negative cosine in the right side, and constant will transpose in the left side. So we have I and x. The value of constant is I n plus c. So therefore we have I n c is equals to cosine v. Simplifying this term, so we need to let again, so let I n b is equals to I n a over b. Therefore, these two value here will become I n x over c is equals to cosine b. So we have this. This is not still the final answer. So we need to rewrite our equation. So we cope up with I n x over c equals to cosine b. So we need still to simplify this term, and we all know that the value of our y in the first is bx. So we need the value of b. So this is the technical error. Therefore, the value of b is equals to y over x. So we have I n x over c is equals to cosine. Since the value of b is y over x, so we have y over x. And this is the final answer. I n x c is equals to cosine y over x.
So we have here our example number 5. So can we solve dy over dx is equal to x squared plus y squared over xy. So can we get it in this equation? This style. So first, let's start off with this equation. Plus y squared over xy. Then we separate the term and we turn it into this. Y squared over xy. And then we simplify this. X over y plus y over x. So for our reciprocal, the first term, we have y over x minus 1 plus y over x. Yes, we have this function. So let's start. First, we start with dy over dx is is equal to y over x minus 1 plus y plus iy over x. So y is equal to x, and dy over dx is equal to v plus x dv over dx. V plus x dv, oh no, this is dv over dx is equal to v negative 1 plus v2. So subtract from the both sides. Subtract v from the both sides, sorry. So it will turn into this equation. dv over dx is equal to v minus 1. Now, sorry. Now we separate the variables, and it will turn into this. dv is equal to 1 over x dx. So, put the integral sign in form that will be turning into this. Oh, sorry. dv is equal to 1 over x dx. Another, we integrate this value. It will be like this. v squared over v equal to ln times x plus c. And then we make it into c is equal to ln times k. So v is equal to ln x plus ln times k. Then combine that into v squared over 2 ln divided in k times x. And we simplify this equation. So v is equal to positive negative the square root of 2 ln times k x. This. And now we substitute those value of v is equal to y over x. Substitute it into v is equal to y over x, to y over x is equal to positive negative the square root of 2 ln times k x. And then we simplify this equation that will be turning into y positive negative s the square root of 2 ln kx. And there you have it, the answer. Final answer.